Assalamu alaikum. In this video, we are going to be doing more examples and solutions for the circular motion on the surface of the earth. Now, I'm going to be taking examples and questions from the book Al-Murih fi Al-Fiziya. This is the question bank that I am using. Bear in mind that the book itself provides the questions in Arabic language, and I am translating the questions from Arabic to English as they are the questions from past papers on the Sudanese secondary certificate exams. I am using an Arabic question bank because I do not have access right now to an English question bank from English language past papers. But if anyone who's watching the video has a question bank from the English past papers, they can share it with me, and I will be posting problem solving videos using the English question bank. Grab your pen and paper. You can pause the video whenever a question is posed, so you can try solving yourself, and then resuming the video so we can solve together. And Bismillah, let's start. So our first question is a car of mass 2 tons moving along a circular path. We want to find the banking angle if the centripetal force is 2 by square root 3 by 10 to 4 newtons. And we are taking G to be 10 meters per second squared. So we have a mass of 2 tons, which is 2 by 10 to the power of 3 kilograms. And we have a centripetal force of 2 by square root of 3 multiplied by 10 to power 4 newtons. So the formula we have is that centripetal force F equals mg tan theta. So we can solve for tan theta by dividing both sides by mg. So tan theta equals F over mg, which equals 2 by square root of 3 multiplied by 10 to the power of 4 divided by mg, which is 2 by 10 to the power of 4, because it's 10 to the power of 3 multiplied by another 10, which is g, so it's just 10 to the power of 4. And I put it in such a way, not in this way, because sometimes you might get confused when you are dividing a fraction with a number or with another fraction. It's always easier to just write it like this. Write it linearly, and then switch the sign from division to multiplication and reciprocate the other number. So 2 by 10 to power 4 with 2 by 10 to power 4, and we have tan theta equals 1 over square root of 3. So theta equals tan inverse of 1 to square root of 1 over square root 3, and you can leave the answer like this, because sometimes you get a tan of an angle that you already know, but If you do not get a known tangent for an angle, you can just leave it as a tan inverse, but you have to put it in such form, like theta equals tan inverse. Alright, so we can move to the next question. A cycler on a curved path with a radius of 10 meters, going with a velocity of 5 meters per second. If the combined mass is 60 kilograms, find the centripetal force and the required banking angle. So we have a radius of 10 meters, a velocity of 5 meters per second. The combined mass of both the cycler and this bicycle itself is 60 kilograms. We need to find the centripetal force. F equals mg tan theta. We don't have theta, we don't have tan theta, so in this case we have two options. The first option is we can find it from the circular motion formula, which F equals mv squared over r. The second option is solving the second part, finding the banking angle first and then coming back to find the centripetal force. So we can do both. Let's do V equals RG tan theta. And since we want to find tan theta here, we can do squaring both sides, RG tan theta, and then dividing by RG both sides. So tan theta equals V squared over R multiplied by G. V squared is 25 because V is 5 meters per second. Radius is 10 and G is 10, so it's 100. So tan theta equals 0.25. So theta equals tan inverse of 0.25, and we can go back here and find F equals M 60 multiplied by G 10, so 600 by tan theta, which is 0.25. And this equals 150 newtons, because you can take 100 here multiplied by 0.25 and you end up with 6 multiplied by 25, which equals 150 newtons. You can do the other way, which is 60 multiplied by 5 squared, which is 25 also, divided by R, which is 10 with the 60, so you end up with 6 multiplied by 25, which equals 150 newtons. Now when you are using two formulas to solve the same thing in the same problem, you must end up with the same answer. If you do not end up with the same answer, then there is a problem, because you are looking for the force and the force is the same. The force does not care which formula you're using. The force is the force. So if you use two different formulas for the same thing on the same problem, you must end up with the same answer. All right, now let's go to the last example we're doing. So for the last question, we're having here a body moving along a curved path. A curved path having a centripetal force of 75 newtons. If the normal force is 150 newtons, find the banking angle. So here we have to fiddle with the free body diagrams again for this question, because this is not a question about velocities and such. We have a body and we can put a free body diagram for this body here. It's moving along a curved path with a centripetal force. Let's say that the centripetal force is to this direction, F, that is equaling 75 newtons. And naturally, gravity, or the weight of the body itself, is going straight down. So this is mg. And of course the body is tilted because it's a curved path and there is a banking angle. So let's say that like this. And the normal force is 150 newtons. And we want to find the banking angle. The banking angle is here. This angle here, which is theta. Now, what we can do is make a right triangle, and we can immediately find that this line here is the centripetal force, so this is 75, and this line here is the normal force, which is 150, and we have a right triangle, so we have an angle here. We can call this angle beta, and you can see that immediately cosine beta equals the adjacent divided by the hypotenuse. So 75 divided by 150, which equals 1/2. And if cosine beta is 1/2, so the angle beta equals 60 degrees. Now, beta plus theta equals 90 degrees. So the banking angle, which we want, theta, equals 90 minus beta, which equals 90 minus 60, which equals 30 degrees. Now, for people who are watching this video, they might have noticed that I went a long way, because I made an angle here and then used it to find this angle, while there is a shorter way, and which I did not use immediately because I just wanted to solve it in the simplest, most known way possible first, and then introduce another thing. For people who do not know, if you have two angles, angle A and angle B, and those angles add up to 90 degrees, not radians, degrees, then sine A equals cosine B, and cosine A equals sine B. And this is for all values for A and B that can add up to 90. Doesn't matter. If A is 10 degrees and B is 80 degrees, then sine 10 equals cosine B, cosine 80, and cosine 10 equals sine 80. Even if they are not whole numbers. If we're saying we have one angle of 66.7 and another angle of 23.3, if they add to 90, which I think they do, I just made up numbers, but I think they do add to 90, then sine 66.7 equals cosine 23.3, and cosine 66.7 equals sine 23.3. And you can see that on the angles we already know. We know that sine 30 is 1 over 2. Cosine 60 is 1 over 2. While cosine 30 is square root of 3 over 2. And that is the same as sine 60, which is square root of 3 over 2. Why? Because 30 plus 60 equals 90. Now, even 90 itself, sine 90 is 1. And cosine 0 is also 1, because 90 plus 0 equals 90. Look at 45. 45 degrees is the angle that has the same sine and cosine. Why? Because 45 complements itself. So what does this have to do with our question here? Well, it has to do that we can discard of beta. We don't have to find beta first and then subtract it from 90 so we can find theta. You can immediately say that, well, if I have the cosine of this angle, which is 75 over 150, then the cosine of this angle equals the sine of this angle. So theta, or sine theta, equals cosine this angle, which is 75 over 150, which equals 1 over 2, which equals 30 degrees. So in any ways, the final answer, as usual, is going to be theta equals sine inverse of 1 over 2, which equals 30 degrees. Now, it equals 30 degrees because I already know that the sine inverse of 1 over 2 is 30 degrees, or that I already know that sine 30 is 1 over 2. But if you do not know, if you get different number, you can just leave it as such. Alright, but for this question here, it's a pretty obvious one. We're just going to put it as 30 degrees. So that's it for today's video. I hope that it was useful. I hope that you can use these questions as example for future problems or for any problems that you might face. And if you have any specific problems, you can post it in the comments. And also, again, if anyone has a question banks from the Sudanese certificate exams in English, not translated, they can share it with me so I can use it for future videos. But until such time, I am going to keep on using the Arabic question bank المريح في الفيزياء and translate it myself to English. I'll just translate the questions and do the answers. So thank you, and I'll see you in future videos.